Assalamu alaikum everyone. Today the topic that we are supposed to cover is 12.4, that is the refraction of light. It is chapter number 12, Geometrical Optics. In this topic we are supposed to learn and understand what exactly refraction is. We'll talk about the refractive index of certain materials or mediums. We will talk about the speed of light in a medium and how it changes when light or ray of light specifically enters from one medium to another. We'll talk about certain conditions. For example, if the ray of light is entering from a rarer medium into a denser medium, and what happens to the behavior of light when it enters from a denser medium to a rarer medium. We'll compare both the conditions, and we'll also talk about Snell's law and solve a problem relating it. Okay, beginning with the refraction of light, what exactly refraction means. Talking about light, it travels in a straight line, but when it is reflected or when it moves from one medium to another, it does not do so. Which is, we cannot say that it keeps on traveling in the straight path. Whereas what happens to the beam of light when it enters from one medium to another or when it is reflected? Our point to discuss here is that what exactly happens to the light when it enters from one medium to another. The bending or the change of direction of light will take place in such a case. For example, assume or suppose that the light is entering from air, a medium, to that of water, another medium, right? So, whereas air and water both have different densities, which one is the rarer? Obviously, the air is the rarer medium, and in this case, water is the denser one. What will happen if the ray of light is entering from a rarer medium to a denser medium? It cannot keep on traveling the straight path, instead it will bend at some point. In this lesson, we'll get to know that exactly how light bends when this is the case. It will give us some intuition that how to think in terms of light, or what path will light take when it enters from one medium to another. This bending takes place because light travels with different speeds in different media. The speed of light does not remain the same throughout. It depends upon the density, and density depends upon how denser the medium is. If we talk about the microscopic scale, this has entirely something to do, in fact much to do with the particles that are involved in the medium. The more the particles, the more denser the medium is. The lesser the particle, the less denser the medium is. If we talk about density, we are talking about the refractive index. Refractive index is a term that is associated with the density. Every medium has a specific density and so has a specific refractive index. The refractive index for air is 1, and that for water is 1.33. We have to talk about that what is the role of refractive index in the speed of light, or what is the relationship between the two. The speed of light in vacuum means nothing, is 3 into 10 to the power 8 meters per second, which is a universal constant and has to be constant throughout. Whenever we are talking about the speed of light in a vacuum, it has to be 3 into 10 to the power 8 meters per second. Although the exact value that is known at this point is 299,792,458 meter per second. But approximately we are able to write it as 3 into 10 to the power 8. The index of refraction of a material is defined by N is equal to C over V. where n is a symbol that we use to represent refractive index or index of refraction of a certain material. And whenever we are supposed to find out the index of refraction or the refractive index, this is the formula that we have to follow. The formula says that refractive index is equal to C over V, where C, as already discussed, is 3 into 10 to the power 8 meters per second, and V will be the velocity of the speed of light in that particular material for which the refractive index we are supposed to find out. So, whenever we have one unknown and two knowns, we can use this equation to find out the third unknown. Here, c is the speed of light in a vacuum, and its value is 3 into 10 to the power 8 meters per second, and v is the speed of light in the material as already discussed. Whenever the ray of light enters from one medium to another, it bends. And we have also talked about the thing that the speed of the light does not remain the same. There is another thing that does not remain the same. If we are talking about light, we are talking about wave in particular. And if we are talking about wave, there are certain terms that we are supposed to use. For example, in the case of wave, we are supposed to use the wavelength. What happens to the wavelength when the ray of light enters from one medium to another? Physics says that if the speed changes, the wavelength changes. In wave equation, we have studied that V is equal to F lambda. If the speed changes, the wavelength of light changes when it passes from one medium to another. But there is one factor that does not change, and that's the frequency. Frequency remains the same throughout. If we'll arrange the above equation, that is n is equal to c over v, for v, that is the speed of light in the material, this is the equation that we get. V is equal to c over n. And if we find out the lambda, which is the wavelength for this particular material, that what exactly will be the wavelength of the wave in a material that is equal to the wavelength of the wave in vacuum divided by the refractive index. That's another formula. This is a numerical problem that will help us to solve equations or help us to know this equation more. For example, we are supposed to calculate the speed of light in diamond, and because we talked about that specific materials has specific refractive indices, so the refractive index for diamond is given, which is 2.42, which obviously shows that diamond is much denser. As we are supposed to calculate the speed of light in diamond and the refractive index is given, so we are able to do that. We are supposed to use the formula V is equal to C over N, where C is a universal constant and has a value of 3 into 10 to the power 8 meters per second. Refractive index is a constant and will not have any units. The refractive index, the value of refractive index is 2.42 and is given in the question. We have to plug in the values. In this case, C is equal to 3 into 10 to the power 8 meters per second and N is 2.42. By dividing this, that is the value of speed of light in vacuum, by the refractive index of the diamond, we get 1.24 into 10 to the power 8 meters per second. This is the usage of this formula. This is how we can use this formula. Whenever we have two knowns and one unknown, we can arrange the formula according to the unknown and find out the value of that unknown. In this case, the unknown was the speed of light in diamond, whereas the knowns were speed of light in vacuum and the refractive index of the diamond. We plug in the values and reach the final answer. Do not forget that the units are meters per second because we are concerned with the velocity. We have to study Snell's law because Snell's law guides us about the behavior of light when it enters from one medium to another. Snell's law is really important when we are dealing with the refraction. When light moves from one medium to another, some is reflected at the boundary. We do have laws of reflection as well, but in this particular topic we are dealing with the refraction, and some is transmitted, that is, goes through. But exactly we are concerned that how it will go through and exactly at what angle. The transmitted light is refracted. Refraction means bending of light. You can see that we have an incident ray here. This is the incident ray. We have two mediums. One is the air. This is another medium, which is the water. Air is the rarer medium in this case, and water is the denser medium for sure. Air has a refractive index that is given by Na, and water has a refractive index that is given by Nb. Because these are two different materials, so we can say that both the materials are having different refractive index. Now, there is a line which is called as normal. A normal is a line that is drawn perpendicular to the surface. If we see that the surface is this line, and the line that is drawn perpendicular is this line, which we will say as normal, or which is the normal. Now, the angle of incidence is the angle between the normal and the incident ray. In this case, theta A is the angle of incidence, whereas the angle of refraction is the angle between the normal and the refracted ray. In this case, it's theta B. Okay. What is exactly happening to the ray of light when it enters from a rarer medium to a denser medium? It will bend. But how? It will bend towards the normal. If this is the normal, then one can see that the ray of light is bending towards the normal. This is exactly what happens when a ray of light is entering or will enter from a rarer medium to a denser medium. You can see that Nb is greater than Na. That means that water has much higher refractive index than air, which also makes sense. Okay, if we see at the other situation, in this case, the ray of light is entering, or we can say that incident ray is entering from this point, which means it is passing from water to air. Now you see that in this case, Na is greater than Nb. Which means that Na is that of the water and Nb is that of the air. So, as water is a denser medium and air is a rarer medium, so we can say that Na is greater than Nb. Incident ray is entering from water to air, and unlike this case, in this case what exactly is happening, that the ray of light is bending away from the normal. In this case it was bending towards the normal, whereas in this case it is bending away from the normal. This is what we can say about the behavior of light when it enters from a denser medium to a rarer medium, in this case air. We can talk about the angle of incidence. In this case, the angle of incidence would obviously be from water, and we can say that it will be the angle between the normal and the incident ray. Whereas the angle of refraction would be the angle between the normal and the refracted ray, that is given by theta b. Okay, so what exactly is Snell's law? Snell's law is a statement that gives us or says NA sine theta A is equal to NB sine theta B, where Na is the refractive index of the medium in which the incident ray is. For example, if we talk about this case, then the incident ray is entering from air and is entering into the water, that is theta b or NB. NB means the refractive index of the medium in which the refracted ray is. Theta A is the angle of incidence, whereas theta B is the angle of refraction. As already discussed and defined, theta B is the angle between the normal and the refracted ray. So this is the equation for Snell's law. Light passing from water. The refractive index for water is approximately equal to 1.33 and that of air is approximately 1. Light bends away from the normal to the surface as it speeds up in air. So this is case number 2 that is discussed. We discussed that whenever the ray of light will enter from a denser medium to a rarer medium, what will happen? It will bend away from the normal and is given in the diagram. If we plug in the values for this case, Na is the refractive index of the medium in which the incident ray is. For example, for water, what is the refractive index for water? That is given here. It's 1.33. Okay, and sine theta A. Theta A is the angle of incidence. Angle of incidence would definitely be the angle that is between the normal and the incident ray. That's not given, we'll just write it as it is, which is equal to the refractive index in which the refracted ray is. In this case, the refracted ray is in air, so the refractive index for air is given, which is 1. And sine theta b is the angle of refraction. In this case, it is the angle between the normal and the refracted ray. Theta a is smaller than theta b, as we discussed that whenever the ray of light enters from a denser medium to a rarer medium, it bends away from the normal. As a result of that bending away, it will make a greater angle. As you can see, if you compare the two angles, that is one from here, that is normal and the incident ray, and the other one from the normal to the refracted ray, you observe that the angle between the refracted ray and the normal, that is the angle of refraction, is greater. So we can say that theta A is smaller than theta B, or theta B is greater than theta A. So in this case, you can use the Snell's law to find out exactly any unknown. If you know the refractive index of the incident ray, like the medium in which the incident ray is, if you know the angle of incidence, if you know the angle of refraction, and you're supposed to find out the refractive index of the medium in which the refracted ray is, you can arrange the formula in such a way that this thing comes on one side and the rest on the other, and you can plug in the values and compute the unknown. Homework assignment. You're supposed to do the conceptual questions 12.2 and 12.3 on page 66. The statement for 12.2 is, in your own words, explain why light waves are refracted at a boundary between two materials. You're supposed to discuss that exactly what are the possible reasons and what exactly happens when a ray of light is refracted by a boundary. In 12.3, you are supposed to explain why a fish underwater appears to be at a different depth below the surface than it actually is. Does it appear deeper or shallower? You are supposed to use the law of refraction, that is the Snell's law. You are supposed to use the concepts, the bending of light and how exactly it bends when it enters from a denser medium to a rarer medium. You're supposed to discuss that exactly what happens to the light, what factors change and what doesn't change at all. Thank you so much for your time. Bye-bye. Have a great day.